Hi everyone, and welcome to the channel. My name is Antonin, and I am a maintainer for Project Antrea. In this video, I want to discuss one of the most popular features of Antrea, which is the egress feature. Egress lets you decide which source IP your pods are going to use when they talk to services which reside outside of your Kubernetes cluster. Antrea obviously has a lot of cool features, but this one, egress, often comes up when users talk about why they chose Antrea as their Kubernetes network provider. In this video, we are going to cover the basics of egress by looking at an example use case. Let's assume that we have a deployment like this one. We have one network connecting 4 different virtual machines. 3 of these VMs constitute a Kubernetes cluster, with 1 control plane node and 2 worker nodes. The 4th VM is external to the cluster and is running some service. In this case, the service is a simple web server, but in practice it could be anything. For example, a database. For legacy reasons, or because of how my organization works, let's assume that this external service cannot be run as a container inside my Kubernetes cluster. I have 2 namespaces in my cluster, one for production and one for development, and they both run the same 2 applications, called App1 and App2. For security reasons, I want to ensure that only applications from the production namespace can access my external service. Now, one way to do that would be by using network policies. In particular, as a Kubernetes administrator, I could leverage Antrea cluster-level policies to ensure that only the production namespace can access the web server. But we're going to make another assumption. We're going to assume that my external service sits behind a firewall, and that by default, the firewall rejects all connections to the service, except if the source IP has been previously whitelisted. In my example, the firewall I am using is Linux IP tables, but in practice, it can be any software or hardware firewall, including a commercial appliance. This assumption is not that unreasonable, and this scenario is quite common in some industries. So now, let's summarize the requirements that we have. We have a network firewall, protecting access to the external service. By default, the firewall is rejecting all traffic. If we want to allow some connections to access the service, we need to explicitly whitelist the source IPs for these connections. We want all production traffic, that is, traffic from the prod namespace, to be allowed to access the service. In other words, the network firewall should not reject connections coming from applications in the production namespace. However, all traffic from the development namespace should correctly be rejected by the firewall. Finally, we're going to add one more requirement. We want the firewall to see different source IPs for App1 traffic and App2 traffic. This way, when network admins look at the access logs for the firewall, they should be able to tell the difference between App1 and App2 traffic. Antrea Egress offers a solution to meet these requirements. Before diving into a demo, let's look at the Kubernetes resources that we will create. We are going to create 2 egresses, one for the production App1 and one for the production App2. We are also going to create one external IP pool resource. Those resources, egress and external IP pool, are Kubernetes custom resources. They are defined at the cluster scope and not at the namespace scope. The first egress that you can see in the top left corner selects all App1 pods in the production namespace. As you can see, if you look at the applied to block in its specification. Similarly, the second egress, which you can see in the bottom left corner, selects all App2 pods also in the production namespace. Both of these egresses will reference the same external IP pool, which is defined on the right-hand side of the slide. The external IP pool will use a predefined range of 10 IP addresses. All of this means that whenever a pod from app 1 accesses any external service, it will use a source IP from that range of 10 IP addresses. And whenever a pod from app 2 accesses any external service, it will use a different source IP from that same range of IP addresses. Because we use a predefined range, we're able to use the following firewall rule that you can see at the bottom. It will only accept traffic from production applications. And because the two apps will use two different IP addresses from that range, we should still be able to distinguish between the two apps, for example, when we look at the firewall logs. For the sake of convenience, we will also create similar resources for the development namespace. But of course, we will use a different IP pool with a different range of IP addresses. Once we create all these resources, our setup will look like this. Applications from the production namespace will be able to access the web server sitting behind the firewall. Each application will use its own source IP allocated from a predefined range. On the other hand, applications from the development namespace will not be able to access the web server. These connections will be rejected by IP tables. And now it's time to move on to the demo. So this is the Kubernetes cluster I'm going to be using for the demo. As you can see, it has 3 nodes, 1 control plane node and 2 worker nodes. Of course, I've installed Antrea as the CNI for this cluster. I've also created a dev namespace running my 2 applications, app1 and app2, and a prod namespace also running those same 2 applications. As you can see, app1 is running as a deployment with 2 replicas, while app2 is running as a deployment with a single replica. On my other terminal, I'm actually logged into my external VM, which is running my web server as a Docker container, and it's listening on port 80. And if I look at the input chain in IP tables, I can see that I have a single role which is rejecting all HTTP traffic. So it's rejecting all connections to port 80, which is the port on which my web server is listening. I can now go back to my first terminal, and I've created a script which is used to check connectivity from my application pods to my external web server. If I run my script for the prod namespace, we can see that all 3 connections to my web server are refused, and we get the same result when we run the script for the development namespace, the dev namespace. Now things are going to get interesting because I'm going to be creating and configuring my egresses. Let's look at what we have, and first let's look at the external IP pool for the production namespace. So you can see that range of 10 IP addresses I was mentioning before. This is the range we want to use for the source IP of my pods running in the production namespace. And if we look at the external IP pool for the dev namespace, we can see that we have a very similar resource, but of course it's using a different range of IP addresses. Because I only have 2 applications running in each namespace, I actually only need 2 IP addresses, so I would actually need a range of only 2 IP addresses, but for the sake of this demo, I've allocated 10 IP addresses in each case. And by the way, those IP address ranges are reserved from the network to which all my VMs are connected. We can go ahead and create those 2 external IP pools. Alright, so my IP pools are created. I'm actually not referencing them in any egress resource, and so right now they're not being used for anything. Let's look at the egress resources now, starting with the ones for the production namespace. So those are the ones you saw on the slides previously. You can see that the first one here is selecting app1 pods in the production namespace, and the second one is selecting app2 pods also in the production namespace, and they're both referencing the same external IP pool, the one that I just created. So let's create those as well. And then we have the same thing in the dev namespace, or for the dev namespace rather. And of course, those two egress resources for the dev namespace here are referencing my other external IP pool object. Alright, so all my egresses are created. If I use my script to check connectivity again, well, nothing has changed. And that's because I haven't configured my IP tables firewall yet to accept connections from the prod namespace. And I'm going to be doing that right away. So I prepare the role that I talked about before when I was going over the slides. I'm just going to copy it, and here we go. So let's look again at my input chain. Okay, we can see my new role here at the beginning of the chain, taking priority over the reject role, and it's gonna accept all the traffic coming from this IP address range. Once again, this is the range that is being used for my production namespace, as you can see on the screen. All right, so my egresses are created, my firewall is configured, and now I should be able to check connectivity from the prod namespace again, and this time it should succeed. All right, we can see that all three connections have succeeded from the two app1 pods and the one app2 pod. The nice thing about this web server that I have running is it's actually returning to me the source IP address that was used to access the web server. And so we can see that the first IP address in the range, in this range here, that first IP address was being used by pods from application 1, and the next IP address in the range, ending in 201, is being used for pods. Well, there's a single pod here, but for the app2 pod. However, if I check connectivity for my dev namespace, nothing should have changed, and all those connections should be refused. There is one more thing I want to discuss about egress, and it is the failover capabilities. But first, we need to understand a bit more about how the egress data path works. Each egress is assigned to a specific node in the cluster. The node selection process depends on how the external IP pool resource is defined, as it includes a node selector field. Two different egress resources can be assigned to the same node or can be assigned to two different nodes in the cluster. What's important to understand is that all the pod traffic to which this egress policy applies will need to transit through the egress node on the way to its final destination, which is outside of the cluster. In this diagram, we have an app1 pod running on the first Kubernetes worker node. And the egress for that application, called egress app1, has been assigned to the other worker node in the cluster, the second worker node. Whenever the app1 pod needs to communicate to the external service, the traffic first needs to transit through worker node 2. So what happens if worker node 2, also known as the egress node for this specific egress resource, goes down? Will app1 lose its connectivity to the external service? Well, thankfully no, because the egress implementation in Antrea includes a failover mechanism. If an egress node goes down, its egress resources will be reassigned to another eligible node in the cluster. In the updated diagram, we can see that app1 can still communicate with the external service, as the egress resource is now assigned to worker node 1. So how about we see this failover mechanism in action? So we are back in the Kubernetes cluster and we still have our 4 workloads. We have 2 apps in the prod namespace and 2 apps in the dev namespace. And we can double check connectivity to the external service. So as before, apps in the dev namespace cannot access the external service, and apps in the prod namespace can access the external service through the firewall using an egress IP. And we can take a look at the egress resources that we previously created to make this work. So we have our 4 egress resources, and we can see that 3 of them have been assigned to node worker 1, and 1 of them has been assigned to node worker 2. So as an experiment to test failover, what we're going to do is I'm going to take down node worker 1, and we should see those 3 egress resources be reassigned to node worker 2. Before we take down that node by actually destroying the virtual machine for that node, I'm going to manually drain the node that I'm going to destroy. And the reasons why I'm doing this is because it can take a while in practice for Kubernetes to realize that a node has gone down and to move over the workloads to a new node. And we kind of want to avoid that because it can take like several minutes. So for the sake of this experiment, I'm doing it manually. And as soon as the node has been drained and all the application pods have been moved to a new node, we're going to be able to destroy node worker 1 and actually validate that the egress resources fail over to a new node. Okay, so the node has been evicted. Let's quickly double check. So we can see that all the pods have been moved to node worker 2, and we should be able to see the same thing for the dev pods. Okay, perfect. So everything is on node worker 2. From an egress perspective, nothing has changed, right? Because the node has just been drained. It has not been killed, not been destroyed. And so the egress failover mechanism built into Antrea has not kicked in yet. Let's just double check that with all of this, connectivity is still what we expect. So it's good for the dev namespace. We don't have connectivity to the external service. And for the prod namespace, still great. We still have connectivity to the service using the same egress IPs. All right, so now we're in a good shape to actually destroy the node, which in my case means like destroying the Vagrant virtual machine used to implement the node. There we go, it should be asking for confirmation. Yes, I'm sure. There is no going back at this point. All right, and the failover mechanism is very fast. So, oh, here we go. I'm looking at the egress resources again, and I can see that all of them, the IPs haven't changed, but they have been reassigned to node worker 2. So if you compare to the top of the screen here, you can see that all those egress resources have been reassigned to node worker 2. Now, if I check connectivity, I should still be observing the same things. The only thing that has changed is my data path. All right, so this one's taking a bit of time. Let's see. Maybe it's temporary. Here we go. I don't know why the first one took a bit of time here. Maybe some, I think probably some ARP caching of the MAC address. And we're going to do the same thing for prod. We may see the same delay for the first one potentially. And so as you can see, here we go, it's working. As you can see, the failover was very fast, and that's because Antrea uses a separate failover mechanism from Kubernetes itself. So it's not dependent on the Kubernetes control plane. It's something that's implemented directly into Antrea using networking protocol to check aliveness of other agents. All right, so some of those requests took a bit of time the first time. I think it's because of some ARP caching, but here we go. Now it's fully recovered, and we can see that the test runs very fast and the results are as expected. There is one more test I wanted to run here, which is not really related to failover, but I think it would be interesting. So up until now, we've been dropping all the dev traffic at the IP tables firewall, and we have one role which allows traffic from the production namespace. Now I want to see, what if I remove all the roles from my firewall? Is my dev namespace or the applications in my dev namespace gonna be allowed to access the external service? And that's just kind of like some extra validations that I want to do here. So I'm back into my external VMs, and we still have the firewall roles here. So I'm just gonna flush the input table. Okay, so no more roles in that, in that input chain. And if I go back here, of course, production, nothing should have changed, all right. But if I do the same thing from the dev namespace, now we should see those two IPs showing up. And because we flushed the IP tables chain, applications in dev namespace should now be able to access the service. There we go. So those two IPs here, egress IPs, they show up in the output, which means that those applications in the dev namespace are using those IPs to access the external service. And yeah, everything is working as expected. That's all for me today. I hope that you found this video interesting. If you have a use case similar to the one I described, don't hesitate to give Antrea and Egress a try. You can reach out to the Antrea team on GitHub or find us on the Kubernetes Slack if you have any question. The links will be in the description below. Have a good one, and I'll see you in the next video.